Okay, I'm going to do some of the odd numbered problems from exercise 6.2 Q3. Now in this exercise we're using for the first time substitution rules. And substitution rules are importantly different from the inference rules we've been using in ways that I'll show you as we do these exercises. Okay, so number one gives us one premise, not C or H, and we're asked to derive the conclusion not parentheses C and not H. All right. So if you look at the substitution rules, the most likely culprit here is going to be De Morgan's. All right. So if you remember De Morgan's rule, it tells you that if you have two sentences, not P or not Q, that's logically equivalent to not P and Q. This four dots here just means logical equivalence. And it can go the other way too. If you have not P and not Q, that's logically equivalent to not P or Q. So you can see the pattern here, I hope. First of all, notice the disjunction changes to conjunction, or the conjunction to disjunction. And the negation, if you think of this in math terms, the negation gets sort of factored out. In other words, it gets taken off of each of the individual sentences, and the operator changes from conjunction to disjunction or vice versa. Now, one of the things about the substitution rules is that you can they're called substitution rules because you can substitute one of these for the other. And what that means is you can do it either way. So if you have something that looks like this, then you can substitute something that looks like this. But it goes the other way around too. If you have something that looks like this, you can substitute something that looks like this. So unlike inference rules, which only go one way, right? So think of modus tollens. If you have conditional plus negation of consequent, you get negation of antecedent. It only goes that one way. You need those two inputs to get the one output. But these go either way. If you have this, you can get this, and vice versa. The reason for that is because they're logically equivalent to each other. And if you remember, logical equivalence just means always have the same truth value. So that's why if you substitute this in for this, you won't ever change the truth value. So if a sentence like this is true, and you substitute something that's logically equivalent, then that's guaranteed to be true as well. So you can see this looks a bit like this, and our conclusion looks a bit like this, but the problem here is only one of these things is negated. And to do the De Morgan's, both of them have to be negated. But now we've got a quick fix for that, because we've also got a new rule called double negation, right? So the double negation rule says for any sentence P, it's logically equivalent to that same sentence with two negations. And again, hopefully that's obvious, right? Because if you have P and you add one negation, it changes the truth value. So if P is true, negation of P is false. But that means adding another negation is just going to flip it right back to the original. True, false, true. So that's why you can substitute for any sentence P the same sentence with two negations in front of it. And again, it goes either way. If you have a sentence that has two negations and you want to get rid of them, you can substitute in P for them. But here we needed to have this negated because we want to do this De Morgan's, and De Morgan's requires that both parts be negated. Okay, so now how do we do the De Morgan's? Well, again, remember we factor out the negation, so that negation comes off the C, the disjunction changes to conjunction, and one of the negations comes off the H, but the other one stays on there. Oh, sorry, I forgot to label this one. So this one is double negation of 1. And that raises another key difference between inference rules and substitution rules. Again, one key difference is with substitution rules, you can go either way. If you have this, you can go this way or the other way around. The other difference is you can apply substitution rules to parts of sentences. Right? We only applied double negation here to the H. We left the rest of the sentence just as it was. Again, that's different from inference rules. Inference rules have to be applied to whole sentences, right? Or to the main operator of a sentence, and only the main operator. So if you have a conditional, you can, and a conditional and an antecedent, you can do conditional elimination. But the main operator has to be the conditional. Here we can apply the substitution rules to parts of sentences or to whole sentences, whatever we want to do. So here we applied two negations to H, so that's why it's double negation of 1. And then here we applied the De Morgan's rule to line 2. Substitution rules are only going to have one number because, again, you're substituting one thing for another. So it's always going to be what you substitute. So we substitute this and this. So the Morgan's 2. Okay, so that was number 1. Let's look at number 3. And remember, adding these rules, everything else we had was still in play. It's not like we're losing anything. We're just adding new rules into the mix. So everything else we've done is still available to us. Okay? Alright, so here we need to get not I. And again, there's not really anything we can do just looking at our premises. Well, we could do a De Morgan's on 1. If we do that, we would get not I or not J. And we could get rid of those two negations by doing double negation of 3. Okay, so then we have not J here, we have this disjunction, so we can get not I, our conclusion, just from, let's see, disjunction elimination of 2 and 4. Okay, so this was De Morgan, so we distributed the negation across both. So I got a negation, J already had one, so it has 2, and the conjunction changed into a disjunction. Then we took these two off using the double negation rule, and that allowed us to do the disjunction elimination because we have disjunction here, negation of one of the disjuncts, that gives us the other disjunct. I was thinking at first we would do a negation elimination, which we could have done, but this is much easier. Okay, number 5. Let's see. Okay, so here we've got 3 premises. We could do a De Morgan's on number 1. That would give us not N or not O. Right? Distribute the negation across both and change the conjunction to disjunction. We have a disjunction here and we have N, but notice N is not the negation of one of the disjuncts, so we can't do disjunction elimination, or at least first we have to do double negation step. Okay, so why do we have to do double negation? Because to do disjunction elimination, we need a disjunction and the negation of one of the disjuncts. N by itself is not a negation of anything. There's no negation there at all. So we can't do a disjunction elimination until we do this double negation. Now, line 5 is the negation of that. So we can go ahead and do our, we can get not O then by disjunction elimination of 4 and 5. Then now we have this disjunction and the negation of the disjunct, so we can get our conclusion by disjunction elimination of 3, 6. So 3 is a disjunction, 6 is the negation of the disjunct, so that gives us as output the other disjunct, and that's our conclusion. Okay, number 7. So what can we do given our premises? It looks like the only thing we really can do is a De Morgan's. If we do that, we get not Q or not P. Right, again, distribute the negation across both sentences and change the conjunction to a disjunction. Okay, so now that we're kind of stuck, given our premises, there's not much we can do. So now look at our conclusion. See what we need to get. We need to get S. And here's S here. Right? So we could get this out of a disjunction by disjunction elimination. But to do a disjunction elimination, we need the negation of the other disjunct. Now you might be looking at premise 2 and going, well, that is the negation of the other disjunct, but it's not, because this one P comes first, Q comes second. This one Q comes first, P comes second. So we have to fix that. And we can do that now with another of the substitution rules we learned. Whoops, this should be not. Which is called commutativity. And what commutativity tells you is that anytime you have a conjunction, a disjunction, or a biconditional, you can change the order without affecting the truth value. So here we have not Q and P, so we change the order when we put not P and Q. And now we do have the negation of this conjunct. So we can go ahead and get our conclusion by disjunction elimination of 1, 4. So here's a disjunction, here's the negation of one of the disjuncts, so that gives us as output the other disjunct. Now notice that first De Morgan step we didn't need. You didn't need to do it, you don't use it at all. But that's fine, as long as you get to your conclusion and you apply the rules correctly, it's not going to be points taken off or anything if you do extra steps. So don't worry about that. And sometimes, you just have to sort of explore and see what, like I said, see what you can do given the premises that you have if you're not sure how to get to your conclusion. Okay, so this will probably be the last one because I only have 15 minutes on this recording and I'm at 13. So let's go quick. Here we need H. We've got conditional, negation of G. So notice that's the negation of this consequence, so that means we can use modus tollens to get the negation of the antecedent. So again, conditional plus negation of consequent gives us as output negation of antecedent. Now we can do a De Morgan's on that. Right, distribute the negation, change the disjunction to a conjunction. We can do conjunction elimination to get each of these by themselves. All right, now we need to get H by itself. Here's not F. We can get not H by modus tollens. So modus tollens, here's a conditional. Here's the negation of the consequent. That gives us the negation of the antecedent. So since the antecedent is not H, the negation of it is not H. So that's modus tollens 2, 7. So then our last step to get H by itself is just to do the double negation on line 8. So the double negation takes off those two negations, and that gives us our conclusion. Okay, so I'll stop there because I'm almost out of time on this video. Hope that helps to some extent applying the substitution rules. But again, use the discussion rooms, post answers you get to the other even ones if you're stuck with them or any of the homework problems, and we'll talk more about them in the discussion rooms.